things related to the oil refinery. The reason why I'm introducing the oil refinery as we speak, and the course is called biofuels, so there is kind of a mismatch between the fossil fuel production oil refinery and then the biofuel production. But later on in this course you might see their similarities and importance, why it's good to know the oil refinery. The one thing is that it's the current major or dominating technology, and all the new products entering the market, biofuels and so on, they are kind of competing with the current oil refinery. So it's good to have a little bit idea what oil refinery is making and how what products are produced today. Another thing is that it seems that one scenario is that these oil refineries will simply keep on going, but they will replace fossil or crude oil or fossil-based feeds with partially at least with waste feeds or with biomaterials, biomasses. So it can be that this biomass that we study in this course, it is simply fed in the current oil refinery processes. Of course, the processes might be slightly modified with certain pre-treatments, purification steps and such, but it might be that the oil refinery will still keep on going for quite some decades. The good things that have been beneficial for oil refining is that there are huge reserves for fossil fuels. It still exists, and there is the petroleum or crude oil. There is a lot of natural gas and coal. So these are the most common types of fossil fuel reserves. Another key factor is that it's quite cheap material. And usually if we offer some bio-based or processed product, biofuel, as an alternative, so it tends to be more expensive, and that's a problem. So nobody wants to pay any extra, although everybody is concerned about the environment and so on. Nowadays the legislation is let's say on the biofuel side, and usually it's so that if you want to change things and do something for the benefit of the environment, so at least based on my experience, so it always requires some legislation, or otherwise the companies would not choose the more expensive or more difficult methods to do the same things that can be done cheaply with the existing technology from crude oil, so to say. Some of the giants in the oil industry coming in terms of the oil or natural gas reserves are Venezuela, Saudi Arabia, and Canada from the northern, like regarding petroleum. And when it comes to natural gas reserves, so Russia is with Iran and Qatar, Turkmenistan, and the largest reserves. Now I'm talking these advantages of crude oil or petroleum. So you can also, like later on we have assignments and things, so you need to somehow evaluate or have an idea what is beneficial, what is disadvantage. And there is not a perfect fuel for all the applications. So for some applications this is good, for other application it's bad, and so on. So but the things that are beneficial or good in terms of crude oil or the raw material that is processed in the oil refinery typically, so it is liquid at room temperature, or you have seen the pictures, it's quite sticky tar like material, but in any case it's liquid like material, and that makes it easy to transport, easy to process. Also the petroleum is non-compressible like gaseous materials, so you can move it or you can pump it through long pipelines and transport from one place to another, and that's a clear benefit as well. Another thing that is beneficial when talking about crude oil, it has been maturing in the ground usually for millions of years, so you can store it very long times without any material losses, without any degradation or changes in the composition, so it's quite stable. If you store it underground so for some tens of years, so it's more or less the same material after that, it hasn't changed much. Also the thing is that when it's liquid like, and it's mostly hydrocarbons, so it has very high energy density. That you cannot say for natural gas or hydrogen or something. It requires compression to have higher energy density. And also this second last bullet point is problematic often with these biofuels. So when we talk about bio-oils made based on pyrolysis, or if we talk about these FAME, fatty acid methyl ester, the first generation biofuels, first generation biodiesel, FAME. So those are not very stable. Those contain water soluble components and many other things that make them degrade by time. So you cannot store this biodiesel for very many months without losing some of the properties and so on. So that's like, these are the few things that have made crude oil so popular. Evident other aspects are, of course, that there is so huge reserves that it can support this massive consumption. I think there isn't any other raw material on Earth that is available in so large quantities as crude oil, natural gas, and coal at the moment. Another thing is that it's so inexpensive that it can be used in a way that we use it today. So more or less everything, majority of the energy, majority of the chemicals and products contain these processed crude oil and fossil-based materials. This elemental composition doesn't tell much, but it tells that in all these fossil fuel materials, so there are these important energy containing elements like carbon and hydrogen. So natural gas is rich in hydrocarbons, so carbon and hydrogen is plentiful. Same applies to petroleum or crude oil, and also with the coal. So otherwise the impurities and other components vary quite a lot what those contain. It depends on the reserve also, if it's from Russia or from Norway or from Saudi Arabia, so the compositions vary. This is also a list of composition of biomass. I think the picture is overlapping a bit. Let's reduce it. Biomass, if you, the elemental composition is quite similar, so it has a lot of carbon and hydrogen, which is good for making of fuels, but there are also other things that are not so good for making of fuels. So oxygen, so it's not always good to have oxygen in the fuel, although these oxygen containing materials are added to some fuels, but there the function is different. But in this biomass, so if you tend to oxidize carbon, and if the carbon already has oxygen attached to it, so the oxidation potential of it's not that high. And therefore, often in some of these biomass treatment processes, so those tend to remove oxygen in order to make it a better fuel. So those are like high oxygen removal, and that is done by treating with hydrogen. So for example, this hydrotreated vegetable oil, so what the hydrogen treatment does, so it removes these oxygen functionalities, oxygen atoms from that structure, making it a better fuel. The petroleum or the crude oil, although I said that it's this liquid-like kind of viscous material, so there are clearly, one could say, solid fraction bitumen and these very long chain hydrocarbons that are more or less solid materials. Then majority of that processed mass is liquid, and it's processed in that oil refinery. Of course, the solid material is taken also their care, and it contains some dissolved gases, but not that much. But one thing that if you consider the composition of petroleum or crude oil that is extracted from underground, so it is very complicated mixture of different hydrocarbons and organic molecules, also some inorganic materials. So the thing to keep in mind that it's really mixture of various components. And for that reason, before entering the oil refinery, so the crude oil often goes into some purification steps. So here it goes to washing, where this different inorganic material is removed, so inorganic salts and so on, because those tend to cause problems afterwards. Also, dissolved gases and potential humidity, moisture is removed to begin with. Once these are taken out, so still it contains like this wanted hydrocarbons, but various organic components that contain sulfur, oxygen, nitrogen elements in the structure, and some metal, trace metals, and also quite a lot of sulfur, hydrogen, dihydrogen sulfide, and inorganic sulfur components. So that's by origin in the crude oil, and many of the oil refining processes is basically what it does. It's separating the hydrocarbons from that mixture, and then it's more or less afterwards removal of these unwanted impurities for various steps in the oil refinery. For example, sulfur is removed because of this acid rain potential. So if the sulfur would be in the fuel, it doesn't cause that many problems in these old-fashioned diesel engines, but it makes this sulfur oxide emissions, and when those enter the atmosphere, they react with humidity, water, and cause sulfuric acid, which is it's strong acid, quite corrosive to certain minerals and so on, and causes this acid rain problems. But since nowadays it's very efficiently moved from the crude oil and oil refinery products, so we don't have any more this acid rain issues. So this also shows that in the early days of oil refinery, so the processes were much simpler. There were only very few steps, and it has evolved nearly 100 years, and nowadays it's highly optimized, quite complex, this kind of versatile facility to make different products. The very early oil refineries were not called refineries, but they were called distilleries or oil distillation units, because there was only the distillation and certain fractions like petrol or something were separated, and majority of that crude oil was waste. Today, the oil refinery leaves hardly or very little amount of waste. So majority of that material entering oil refinery, it's converted to products and used somewhere. So the production process is very efficient in terms of conversion and yield of the products. Minimal amount of waste material is generated. The oil contains different hydrocarbons. We don't need to go into more details, but at least at this point. But there are these paraffins. So those are these saturated hydrocarbons, straight chain or branch ones. Those can be cyclic, then it's called cycloparaffins. If it contains this benzene ring-like structure, so those are called aromatic. And if the rings, in addition to carbon, contain some other atoms like nitrogen or oxygen, so then those are called heteroatom compounds. All can be found in the crude oil. I don't know if this is the correct place, but the crude oils can be found all over the world or at least in more or less all various areas, and they like I said, so the composition is different, and I think I have some examples here. So after distillation, I don't know if all of you are familiar with the distillation. It's a technique where you can separate volatile components based on the boiling point, to put it simple. So when you heat up crude oil, so at room temperature, these very light components evaporate first, and when you increase temperature, so heavier and heavier molecules become evaporated or start to boil. And therefore, by this varying the temperature, you can distill out certain fractions or components from the mixture, crude oil mixture. And here the distillation has been carried out for Norwegian, Nigerian, USA, and Middle East crude oils. And you can see that the composition of different components vary. Here are some product yields based on or different yields of these components that you get out from the crude oil. I took here this just to highlight like how many different types of fractions can be taken out from the crude oil. Otherwise, the table is telling that summer and winter, you don't need to worry about that. There is a small variation in that, but the point is that you can get various hydrocarbons out from the oil and also some materials that are not used as fuels. So here are examples like this lubricating oils. Those are quite important in engines, for example, gearboxes, all sorts of moving items, metal. So lubricants are used in many places. Then the heavy parts or the very long hydrocarbon chains are these asphalts and waxes. Well, those you can use in, for example, in road paved roads. Solid carbon can be made and it has applications, and then this also is quite important, this chemical plant feedstock. Then we are talking about the not oil refinery but the petrochemical industry, which is usually next door to oil refinery, and they'll get their raw material from the oil refinery processes. So it's kind of integrated together, which is often quite sensible and solution. Here is still a more exhaustive list of some petrochemicals derived from the crude oil or oil refinery. Here are alcohols and their derivatives. These are usually these very basic bulk chemicals that are used in huge quantities in our today's, let's say, modern industry. Aromatics are used as solvents or starting materials for making different materials. The olefins are important. These contain carbon double bonds, and these are the monomers that make polymers, so plastic materials, and many others. I think I will not touch much this natural gas as such. Natural gas is used a lot in chemical industry, particularly in Europe and this Ukraine war and cutting of this natural gas pipes coming from Russia was quite a big problem for some time and still is. But chemical industry it's used for energy and particularly for making of hydrogen, and hydrogen is used in making ammonia, and that's used in fertilizer industry and in making also natural gas is you make synthesis gas out from it, and from synthesis gas you can make quite many hydrocarbons, and so therefore it's quite important starting material. These I already mentioned. So natural gas is source for energy, but it's also source for quite important basic chemicals. Coal I will not go again into details. I'll speed up a bit. There are different types of coals. I'm not expert in this coal chemistry. Germany, Central Europe has been using in the few decades back huge amounts of coals to support the chemical industry. So it's very important, has been very important. The importance is getting smaller because of this emission problems related to fossil fuels and particularly use of coal. So electricity and heat generation, it's also important material in steel making, at least has been. Nowadays it's maybe less, also in cement production. And these are topics that we cover in this course later on. Coal is used in gasification and liquefaction and making of chemicals. So coal is a solid hydrocarbon. It contains carbon and it's solid material. Biomass also contains carbon and it's solid. So there is kind of similar processing techniques can be applied to coal and also woody biomass. That's the analogy there. This I already mentioned in the introduction, I suppose. So how the oil refinery looks as this kind of a setup or flow chart. One can find, and there are very many oil refineries in the world, and each of them are kind of unique. So the setups vary slightly and so on. But usually, if you think so, when the crude oil enters here, so there is it's not the purification step, salt removal, water removal is not drawn here, but it first enters the distillation steps. And the distillation it's more complicated, but there you can separate the different useful fractions of that crude oil. So for example, kerosene or gasoline components that could be used as such as products, or at least in the early days. What is not used as such, so they go to some refinery steps. So these are chemically modified. It's called upgrading or refining, and typically there is hydrotreatments, isomerizations, reforming steps, cracking steps, and then you get different products or improved products. And last in the oil refinery, there is the so-called blending station or blending step. I have another picture about that, but there you make those product mixtures that are required, for example, based on this fuel criteria or fuel standards that tell how much of that component, how little or of the other components. So these different feeds coming from different parts of the oil refinery are combined in a desired way in the blending station. That makes the products that go to airports or are used in the cars and so on. So in a simple way, it's something like this. But when you get into more details, so it's very complicated, and my idea is I don't see any reason to go into details, but I have listed majority of the chemical and physical reactions or unit operations that are carried out in the oil refinery. And Here's distillation, extraction, salt removal, hydrogenation, hydrotreatment, so purification with the help of hydrogen, and alkylation, and so on. Cracking is quite common as well. Cracking, like the name says, so it's breaking the long hydrocarbon chain into shorter ones, which are more useful, and many other things happen in the oil refinery. But some of these steps can be also employed in the biofuel production. So in terms of what they do, so it's like some of those steps are like separating components from each other. The most common way to do it is by distillation. Then the treatments can be applied by removing salt, removing some other components. Then one can convert. This is like a chemical operation in a way. You can convert certain starting material into different molecules. You can also use catalyst. Then there are also steps that are like cutting down on the emissions that come out, like sulfur recovery, NOx, SOx abatement, gas treatment, and other operations like making of asphalt or producing wax, base lubricants, and so on. And hydrogen is also produced in all oil refineries. It's an important another raw material that is used, for example, in these hydro treatment steps to remove oxygen, to remove nitrogen, to remove other components. Mm-hmm. I think I will not go through this in detail, but in this figure you can see, let's say, kind of the flow. It's not the real flow chart, but you can see the order that starting from the crude desalting, then the distillation, then vacuum distillation, and how in different steps after different unit operations you can end up with finally with some products. So there are 14 different products specified in this graph in the relevant positions. This graph continues downwards, so these two arrows coming down, it says here to residue upgrading, so that's the next slide here. So the residue, heavy residues coming from the distillation are still refined further into products, so nothing, basically very little goes to waste from this processing. And I took this picture here just to illustrate that the scale is quite large. So these are more like small cities rather than little factories. So in Finland I live in Porvoo, so we have here an oil refinery some tens of kilometers away, but in any case, so I think it employs some nearly 10,000 people, the oil refinery, and it's not a huge oil refinery, but this is just the steam cracker unit that is shown here. So it's like tells something about the amount of material and products being processed or manufactured in these facilities. This is the blending station picture, which I wanted to show you, and few things in this graph. So the blending station is the last one that makes the correct mixture of components in order to meet the standards and make the customer products. So here you see like in these boxes, so you'll see gasoline. Here is the American standard ASTM and the European one EN for gasoline. So in order to make it, so here are some of these feeds that are mixed there together to make that gasoline. Here is gas, oil, and diesel. There are different standards, and the mixture that is made is of course slightly different. Kerosene and jet fuel, and from where it's made, and so on. So maybe it or at least to me, it shows in concrete way that the products that exit the oil refinery, the commercial fuels, so these are quite well controlled and complicated mixtures of different components. So it's not like when you make a bioethanol in a bioethanol production facility, so you have just more or less one product that exits the factory. Here you make like tens of different products, and then you make mixtures out from those. I guess I'm approaching the end more or less. I had just this question. Maybe it's not anymore that relevant, but like one should maybe think that we are thinking about making biofuels and treating biomass. So how does the biomass fit into this today's oil refinery? And what I like to see there is nowadays people tend to talk about this co-processing, and it can be that these biomass fractions are fed into different parts of the oil refinery, and they become mixed with the fossil feed and become the mixture of fossil products and renewable products and so on. So there are steps and unit operations in oil refinery which more or less without big modifications can treat at least blends of biomass or even pure biomass and make products out from them. Similar techniques are used also in this making of processing of biomass. We'll look at some of these techniques later on during this course, but just that there are like common connection points between the current oil refineries and the future maybe biorefineries. So there will be certain merger, and also the feed material is not anymore in the future perhaps the crude oil or natural gas, but it's mixed with biomass, it's mixed with different, let's say, waste fractions and so on. So things change, but some techniques remain.